So now that we know about debugging, and now that we saw our application running, well, know that what it's doing, right? When we call run, what it's doing is basically showing me the name and going through this 4 times, where it prints the name and the repetition and then sleeps for 250 milliseconds, which is almost nothing. I think you need 1000 milliseconds to get a second.
Yes.
Someone said yes in my background, so yes, it is. Now, the problem with this is the application is frozen until this run is done. Right? I can't do anything. The user has to wait for all of this to be done. And here is a bad example where you just get this sleep. But if it was a real connection, such as, hey, I'm waiting for, I get a connection with the server. This whole time that I'm waiting for a connection with the server, your whole application is on pause. Because again, if you remember our rules, our application is stupid, first of all, our computer is stupid. It runs from top to bottom, so line 16, 17, 18, 19, 20, 21. And it can only do one thing at a time. So if it's stuck at line 19, it cannot do whatever's at line 20. And this could become really bad, especially when we have, let's say, a GUI, a graphical user interface, where the user is interacting with it, but there's a part that requires time to load to the server or save or upload or whatever it is, right? So whenever, and again, you can't let the user wait, because as soon as the user waits for anything, the first thing it will do is quit your application, go get to the next guy. Okay? So we want to make something that's seamless, that's never waiting, that you could always interact with it. It would do stuff in the background, but it would never interrupt the user's progress or the user's interaction. That's a better word. So come in something we call threads. And threads is important because, give me 1 second. Threads is important because it allows us to run something asynchronously, multiple things at the same time, rather than it's always going to be one single thing. Or actually, let's do a little graph here. Here are those drawings. Let's draw this. So what would happen with threads is, as soon as you have an application, let's say this is our app, and it has your GUI part and it has other stuff, and let's say it's connecting to the background to save your data to database, well, it doesn't need the user to be blocked for that. So it would put it on a different thread. Okay. And your application will continue working. So this is continue working, this is different thread. So thread, let's say 0. So as this is storing onto the database, the user is still interacting with your application without any issues, right? And as soon as the thread is done, so as soon as this is finished, well, it could synchronize again with the main thread and allow it to understand. You could notify even the user saying, hey, we finished storing your stuff to the database. And this is really important because we don't want this to ever be frozen. We don't want the main thread, I can't spell here, I'll write it down here. We don't want the main thread to ever freeze because of some other task that we're doing. Okay, but then you're going to tell me, but sir, you always said our application is stupid, it can only do one thing at a time. Well, to be honest, even these threads are actually being done one time at a time. I'm going to go a bit further in this, but to be honest, you'll have a class on threads and processes, and this is really important. This is something used in all of your applications, and it's important to understand this. To be honest, the computer really only runs one thing at a time. Actually, it runs one thing at a time for each process that your computer has. So if we go back to our thing here, actually let me clear that. So if we look at my computer, it has really one CPU, but you'll notice it says 8 core processor. So really, the place that it's doing all the calculations, moving and whatnot, is inside the processors. And because I have 8 of them, now that's 8 workers at the same time. Okay? So I have these 8 workers that are going around doing all their, well, each one of them, they're doing their thing, whatever that thing is. Sometimes maybe they share it. But what's going on with threads is we're basically saying that one core split your job in between these two, and it's going to take some time for this and some time for this, and because it's so fast you won't even see the difference. So the optimal thing would be to only have 1 thread per core, but that's pretty much impossible. If you just look here, I already have 3,000 threads running without me doing anything, just the normal stuff in my computer, right? Processes are applications, so 238 applications. Threads is those applications making all of their work into different threads that they could asynchronously run together. Okay? So in this case, we're making a task be divided into, so let's go back to drawing for a second. So we're making a task be divided into threads. All right. Well, actually, let's say this is a process. Let's use the terms a bit better. So a process is an application. So notice I have 238 processes. And let's say in my process, let's say a GUI sample, I have my main thread. So my main. This one usually would have, let's say, the GUI in there. And for anything else that could take time or whatever, I would use a different thread, such as this one. And this is good because we could give tasks that could take time, such as connecting to a server, such as requesting files, such as uploading something, such as, I don't know, making a connection. I'm giving a lot of internet stuff, but let's go, let's say if you're gonna calculate a lot of things, you could do that in the background while the main thread just sees an update. While you're installing a software, right, you would have the progress bar here as it's installing, but it's actually installing on a different thread. So the GUI stays enabled, so if the user ever wants to, he could press cancel as an example, right? So you want these threads to be separate so your software doesn't freeze as much as possible, right? And again, the process has to switch between threads really fast. And again, it runs really fast, so you'll never see any big difference. But the optimal idea for how many threads you should have per process, it should be 1-to-1. And that's how it was designed. But again, even though that's how it's been designed, this is not how it's being used. Okay, and we really can't do 1 process, 1 thread. It's impossible for the way we are. Okay? Any questions about process threads? I see there's a different question. I'll answer that later because it's not related to this. Okay. So this is a really important topic. And by default, as an example, when you run the swing, it runs into 3 different threads together. Okay? Those 3 different threads would be 1 for the GUI, 1 for the main, and 1 for something. I can't remember this by heart, but you can look at it. It does that by default, so your GUI will never freeze if your background has an infinite loop. I remember when I was starting out in programming, by accident, I created a infinite loop such as this. Let's say we do a visual thing, but if we don't get a visual thing, let's say I get something like this and I print. So my first run, second run runs, but then my application is frozen. It's not really frozen, it's just doing this eternally, right? And I actually did that on a server out of my school, and the server was running all of their websites. So as soon as that happened, because I was on the main threads for some reason, they badly configured it. The whole website was out for a whole day because I was doing it from my house and I couldn't access it. So basically, I froze our server because I had this walkthrough going on somewhere. Okay, now the systems are a bit better. So now if this happens, your OS will automatically semi-detect it, and it might do two things. One, it might put it on pause on the side, or two, it might just kill it. Okay? The real thing it might do, it will just switch between one application to the next really fast. So you might not even detect it. But if it really becomes a painful thing, your OS might just kill it. Cool? Alright, so let's see how threads work. So if we go here, you could create a thread multiple ways. One of the ways I showed, actually I gave you some documents for all the different ways. One of the ways is you implement runnable, which is going to require you a couple things. Well, it's going to require you a run, right? And what you need to do is to create a new thread, and you pass it this, which is a runnable object. Okay, or you could directly create a thread, either or. As soon as you create that thread, just click on start, it will do all the stuff for you. If you want to look at the code, you could hold control and go in there and look at how it does all of that stuff. We could ignore it at our level. Okay, so right now I'm directly calling run, but I'm calling this function on the main thread, and this is a bad thing. So what we want to do is create a new thread, and then we're gonna call the run. And the run is gonna automatically be called with the start here. This automatically will call the run function. Again, why is it automatic? Well, we're talking about that observer type of pattern where we give runnable thread to our thread, and it knows it has the function run because it comes from this. So here, now look at what happens if I do this inside. Let's take off this. Rather than doing run, I'm going to replace it with start. I'm going to replace it with start. Now you kind of see that first and second, they're kind of both running at the same rate. And depending on your computer, sometimes you'll notice one is going to probably go a bit faster, go a bit slower. So it really depends, okay? Mine, my CPUs are pretty strong, so they're kind of running both at the same time. If your computer is a bit slower, maybe sometimes you'll see one that's going to gain some advantage on to the other. It depends on what process they are on, how the process is managing the threads, and a lot of these smaller variables. But now, the cool part is, we're getting two things running at the same time. Right? And to be honest, we could have made one of them on a new thread, and one of them on the main thread. Can you tell me why this still works? Well, because the main thread is different from this new thread that's the start. So even though this one is not start, it still functions because this one is going onto a different thread. And remember, the process, the computer, the CPU, will switch between them really fast and try to do each at a good rate. Any questions so far? Because now we're going to go a bit more interesting, I would say. More... actually, well, anyway, let me write this while you figure out if you have a question or not. So threads allows to separate a process, okay, that's usually what we call an application, into multiple different tasks, let's say. And these tasks are going to be executed kind of asynchronously. So this allows us to asynchronously run, or I don't know if that's the correct word, but asynchronously run multiple things or tasks, let's say, at the same time. I think it's synchronously. Anyway, asynchronously. I'm really misspelling this. Factor, show context, change to. There we go. Asynchronously. There we go. So usually you have a main thread. Normally, one thread called the main thread. Right? This is our application, the main. So you got to be careful with the main thread. You do not want to freeze this one. So we tend to put multiple threads for all our tasks. You got to be careful. Creating threads and killing them is also costly. So you don't want to do millions of these threads. You want to do just enough for what you need. And sometimes you'll use these pools, which allows you to have a range of threads where you keep on reusing them. So a pool is something interesting, but that's a future thing. Because creating and destroying threads is expensive. And again, we're going to come to this in the future as we go along. Well, maybe, depends on where you are. But this is a future thing, but it's good to note that there's a pool of threads. Now, one last thing we're going to talk about with threads is there is something called a critical section, or a critical object, or a critical, let's say, value, variable, whatever you want to call it. Something that is critical is important because is required by multiple threads. So what I mean by this is, let's see, a good example would be, can't think of something, but think of me and my friend were eating together, but we only got one fork. We both want to eat, but we only got one fork, and we're not going to be animals to take our hands or something. Doesn't mean you're animal, but I'm just saying. We just want to eat with our hand, with our fork, but we only have one fork. Okay, and if anything, you could make it like this: it's a soup, and we only have one spoon. We both want to eat the soup. How could we do this? Well, you would say, well, I'm going to let my friend eat first, and then I'm going to eat. But then the food's going to be cold by the time you get to it. For sure, it's going to get cold. You're going to say, well, no, I'm going to eat it really fast. Well, you're going to burn your mouth, let's say. Again, we're assuming, we're making little rules. It doesn't mean the world is like this. It's just to get our example going. So again, we have one soup. We might have 2 bowls of soup. Who cares? But we only have one spoon. So the spoon is critical. And if the spoon, for any odd reason, let's say it has, let's say while I was eating my soup, the spoon fell to the ground, well, my friend's going to take that spoon. He needs to know it fell to the ground. Does he want to continue, or does he want to go and wash it or whatever? He needs to know about the spoon. So the spoon in this case is critical. Right? It's something where both threads, they need to know what's going on with it. So if one of the threads took it and modified it, they need to know about that. Another example would be if we go in computers, 2 threads are writing to the same notepad, the same text file. They both need to know if something new has been added or has been changed. Or actually, a better example, this is an example you'll see everywhere. It would be the example of a bank. So there is an account and 2 different threads. One thread deposits, one thread withdraws. Inside that account, the initial amount is, let's say, 1,000, an easy number. They both see the amount, 1,000, and when they both see the amount, so they both say, okay, the current bank is 1,000, they both say it's 1,000. This guy goes a bit faster than this thread and says, I added $500, so the new total is $1,500, right? And this thread is done. But after this thread is done, the withdraw thread is almost done. This guy says, I'm going to remove 50, and the total is it 1,500? Is it 1,450? No, it's not, because the initial value it has, the critical amount, was 1,000. So 1,000 minus 50, the final balance becomes 950. So this is something that's an issue. I'm going to talk about that in a second. Okay, so critical stuff is something that's a bit important to figure out. So because this stuff happens a lot. This thing happened a lot where banks lost money, financial firms lost a lot of money, etc., etc. Okay? So let's see this happening inside our application. So if we go back to our application, you'll notice this print currently is synchronized. Let's go ahead and remove this synchronized. Okay? Now, you gotta note that this print is static. So it's something shared with all of my runnable threads. So I have first and second, right? And we said whatever is static, it's something that's shared with all of them. So even though now we're on different threads, if I run my application, let's see what happens. Actually, that still is fine. What's going on? So it's been a long time. Give me 1 second. So let's put them both onto a different thread. No, this is not working. It shouldn't have access to it. Did I mess up somewhere? Print is here. I print the name. Should have an extra sleep and then a second sleep. And I remove the synchronous. Let's remove the static. The static should be there, but I don't understand why it's not running correctly. Well, it not running correctly, it should actually bug out. Okay, this is their own state. This is not what I want. I want the static here. And I think I messed up somewhere here. This print should be printing that. Let's just make sure runnable thread dot print. I really don't know what I made as an issue. Started and finished. Okay. Oh, okay. Now, sorry, I'm seeing the issue now. So if you notice here, when I'm starting these two applications and they're on the same, they're on different threads. So we have one on second and one on first. Notice that when a job started, the other job is also starting. When this should have made sure that it's not usable by multiple threads at the same time. That's what it was. I was just confusing for a second. So the problem here is first thread shouldn't have started job 0 until this one is finished with its job. Okay? Now, this is what we call critical. This print, again, if you remember the bank thing, let's say that print was the account. The first thread should finish with account before the second one messes around with it. Because if you don't, you notice you get something like this. Where in the middle of this job, and it starts another job, right? And this is a bad thing. And if we give random number here, we said math dot, let's say random, which gives us a value. What does the value give us? Provides us a long. Let me see what value it gives actually. I'm gonna put some random values there. System.out. I'm gonna mess with it. Okay. So it gives us a number that's 0 to something. So what we could do is say times, or actually we could use the random, no, let's just use the math. So we give it a math times something. So let's say times, so it's giving us a number between this to this. So let's say 100. And we're gonna give that, actually let's see the value first. Sorry, I just want to see. So it gives us this number, but I want it to be in the 500. So we're gonna say something times 100. So now if we see it, it should give us, there we go. So we got some that's 300, some that's 3000. Right? Our normal wait time is 500 milliseconds, but now the wait time goes from 300 to a couple thousand. Okay, actually we could reduce that a bit. And what we're gonna do is put this inside this. And you're gonna see it's gonna be a bit more interesting. So now it's gonna say, hey, what are you doing? We're just gonna say, typecast it to it. All of this after it's done. Okay. So actually I didn't put that here. Now, remember, we're assuming that print is like a bank account. We don't want people to access it at the same time because one could be taking out money while another deposits money and the takeout money is gone, it disappears as if it never happened, right? So this is a scary thing. So this should not be, it should be shared, but it shouldn't be shared at the same time. Think about the spoon as well. I can't eat and he eats at the same time. We cannot do that. Now if we run our application, you'll notice that sometimes might be also that the wait time is the same value, so this is a bit of a problem. Now you can see. Sometimes you see the job 2 is started while job 1 is still ongoing. And depending on this, sometimes it's in the middle of one and the other one is already going and moving on and so on. So this is a bit of a scary thing to do. So what we want to do is to enforce that print is finished before the next job starts. So whoever is having the job right now must finish with it before anyone else. So this is when we add this keyword synchronized. So no two people, well in this case no two threads, can use the same function or the same variable. This could have been for a variable as well, these variables, at the same time. But note, it has to be static because they're sharing it. If they're not sharing it, it's their own instance, it wouldn't matter. Cool? So if you notice here, second thread must finish its job before first thread could start. First thread must finish its job before second thread, etc., etc. And this is a really important key thing to do. You guys have any questions? Again, so anything critical, fix by using the keyword synchronized. Okay, and synchronize will force it that it cannot use it. It's gonna lock it, lock the attribute or the function before anyone else could use it. So you must finish with it and let it go before another thread could use it. And this is important. Again, the bank account is the best example. I might have not explained it well. I don't have graphics, but if you go on YouTube and look for this, you'll see a lot of graphical representations of this example. And it's a really important one because this is actually stuff that happens. Cool? So threads are useful because it allows us to do multiple things without holding up the user. But at the same time, they're really scary because stuff like this could happen, where the value gets replaced by something else. And we gotta also remember that our GUIs already use threads. And if you get into Android or anything more complex than our base programming, they're all using threads. And we're gonna see it managing our application, and we need to understand them to be able to manipulate them to our needs. Any questions? Okay, so let me stop the video on threads.